the new test.
Yeah, I'm not supposed to take that.
So, yes, our next test is next block day. So Wednesday. Derivatives of natural log, that wasn't bad. That was Wednesday. That was 1 over the argument times the derivative. Derivative of exponents, also not that bad. Derivative of inverses, not great. It's one of the harder ones. But that's why we'll take 2 days on it. So basically 2 easy topics, 1 hard topic over 2 days, and then we'll test on it leading into the break. How about questions from 325? Oh, we got options here. Kate.
61.
61. Luke, what were you going to say? Which one were you going to say?
73 or 75.
Okay. 73 or 75. Oh, I'm looking at the wrong page. I'm like, we don't know how to do that yet. 73 or 75.
And 61.
We definitely need to do 73 or 75. That's a good call. And they're pretty similar, so either one. And what else? Plan ahead. 77. That's a great set. And if we have more time at the end of that, we can work some more. But that's a good set to go with. All right, 61. Y equals natural log of absolute value of sine of x. It's the absolute value thing that throws us off. And I don't have a good answer for the question you're going to ask, so apologies ahead of time.
I can't believe you.
So derivative of natural log, there's our pink triangle, or our orange triangle. Depends on which period you're in as to which color I used. 1 over...
The absolute value of sine. Or just...
So that's the deal. It's like you look in CalcChat, they don't even include the absolute value. And then derivative of sine is cosine. So the question is, well, where did the absolute value go? And I don't really have a good answer. My partial answer is you can't take the log of anything negative. So part of why it's on there is to make sure that you can log everything in there. Like here's what the sine graph looks like. So when it asks you to take natural log of that, you couldn't use that or that or that
So if it's
unless you absolute value it, and that flops it to the top. Little bumpy road. Then your domain would be all real numbers because you could put in anything and be able to take its natural log. That's not really that's a good reason for why they're there. It's not a really good reason for why they're not there. I think CalcChat goes one more step and says cosine over sine is cotangent, but that's not necessary. $75. We're gonna close today with one like this. So again, this is from our old toolbox of stuff. This is implicit differentiation, meaning the y is kind of buried in the problem. So let's go term by term. Derivative of 4x cubed would be 12x squared. Derivative of, do we want to algebra first here?
Yeah.
Make life a little easier. So let's put the 2 down front. So 2, and then derivative of natural log is 1 over y. But there's more to this one. Times dy dx.
plus 2 dy dx.
Plus 2 dy dx
Equals 2.
equals 2.
Close to you.
Man, it was... On that last test, there were a few people, it was frustrating. They would get the y stuff right, and then they would leave the 2x. It's It's like, you did the hard stuff, right? And then missed what's supposed to be the easy one. All right, anything without a dy dx goes to the other side. And then we can factor out a dy dx.
You could also factor out 2 in total.
Yeah, I sure could. I could divide everybody by 2, and I could. I still could. I'll wait till the end here. Dy dx equals 2 minus 12x squared over 2 over y plus 2, which is not really cleaned up, but it's fine for a safe stop. If we really wanted to clean it up, all the 2's could go away, so 1 minus 6x squared over 1 over y plus 1. And if we really wanted to clean it up, we'd multiply top and bottom by y to get rid of that fraction and a fraction. This is all just algebra now, cleanup work. So definitely free response there. And then sometime later we hit the multiple choice answer. There's one kind of like that on the test next week. The implicit and natural log and power rule and algebra. Again, we just keep adding to our tool bag, and then we keep adding to the list of things that we do even in one problem. 77. Y equals 2 ln x plus 3. And then I've got some differential equation. And the directions say, show that the function is a solution to the differential equation. Yes, sir.
Is x plus 3 inside the log?
It is not inside the log. There's no parentheses. If it wanted to be inside the log, it would need to be parentheses around it to show that it is. So, show that this is a solution to this. We've not done one like this. What we have done is something like show that 3, 4 is a solution to 2x plus y equals 10. What would you do to show that this is a solution to that?
Plug it in.
You'd plug in 3 for x, 4 for y, 6 plus 4 equals 10. Yeah, okay, good deal. Well, it's this is obviously more complicated, but it's the same thought process. I will substitute in y double prime, the second derivative, and y prime, the first derivative, and show that it works. In fact, the fact that it says show means that it will work, just like 6 plus 4 was 10. So y prime, first derivative. Let's see, 2 times 1 over x. What about the plus 3?
That's constant.
Yeah, that's a constant. That goes away.
So 2x.
I'd write that as 2 over x. Just looks a little nicer. So I know y prime. Now I need to do y double prime, second derivative. What's it going to take to do y double prime? Quotient rules. Anybody see a way to sneak around the quotient rule?
Multiply x by -1 for the new product rule.
So you can get out of the quotient rule on this one if you want to rewrite this as 2x to the -1. So now do you want to do quotient rule or do you want to do negative exponents? I think negative exponents because it's power rule. So -2 x to the -2. So that wasn't bad.
What's x?
-2 over x squared. Right.
Oh, never mind.
You're right. You subtract.
Yeah, that's why.
So we got
And those negative numbers, man, that's a source of a silly mistake all year long. Is that? I thought you subtract 1. Yes, you do.
so x
Times
negative 2 of x squared plus 2 of x is equal to 0.
So I substitute in the second derivative, substitute in the first derivative, and let's see, the x's cancel, or one of the x's cancel. Negative 2 over x plus 2 over x equals 0. Yes, it does.
So you don't even have to find x.
You didn't have to find x. It was just show that this is a solution to this. Where this is eventually heading is start with that and come up with that. Yeah,
That sounds complicated.
that's complicated.
So
In fact,
it could be anything. At that
there's a whole course in college after Calc 3 called differential equations, where you start with things like that, come up with those. Obviously, we're a long ways away from there,
Let's just do it.
but some of you
Calculus class.
will get there. Yeah,
Your constant could be anything at that point.
and then
We found a constant.
the class after that. Oops, Calc
Yeah.
3. Then differential equations,
Oh, no.
And then just separate.
and then partial differential equations.
And then you can take physics.
Yeah, and then
I did all. That's where I stopped.
The next class it only gives you equals 4. And
Where
you
did you
figure
have
out
to
the rest
start
of it.
trying?
Okay.
Where did I have to start trying? Calc 3, stuff didn't make sense to me. That was when I hit the wall. That I have to do something different. I was able to. I don't know about coast, but 1 and 2 were fine. 3 was like, this is hard.
What's after partial?
Yeah, I want to know, is there still more math?
I mean, there's more math, but then it's all of this is calculus. That's sort of the end of the calculus strand. You can do matrix math, you can do linear systems, you can do other stuff, but that's kind of the calculus strand.